Once more, hello, hello. Here we are. We've decided to move away from the outdoor camp quarantine. We're gonna instead hunker down here in the bunker of the basement right here. This is the Hunker bunker, and while we're in isolation, this isolation situation, we're going to do some education for the kids. So they'll go school on the older chalkboard there. Here we are, and we're going to talk a little bit about our wonderful number system here. You got the old decimal number system. As we all know, decimal, deci, of and relating to the number 10. You can have different systems. We call our system a base 10 system because of that decimal right there. That means that each of our place values can only have, you guessed it, up to 10 before we move up into the next place value. So that means that we can have, for example, in this ones, I can have 8 in the ones right there. But if I have 8 apples and get given 2 further apples, I can no longer stay in this place value. I have to take those 10 and it comes 1 here and a 0 here. Now what we're really thinking about is also that's true of any of these place values, even going into the decimals that are on the other side of this decimal place here. I can only have 10 before I move up. So if I have 9/10, I'm going to be right here. But as soon as I get another 10th, I move up and end up having 1, 1 and 0 tenths. So when we move any number up a place value, we're effectively making it 10 times greater because of this decimal system. So I've got the number 39.4. Really, I should say 39 and 4 tenths. In my next number, which is 54 and 1/10, you'll notice the 4 has moved from here to here. That means it's worth 10 times more. Alternatively, if I have the number 91 and then I have the number 0 and 16 hundredths, this 1 has moved 1 time that way, so it is 10 times less, or 1/10. Because of what we know about multiplying by fractions, we know that 1/10 is the same as dividing by 10. So it's 10 times less, 1/10 of the previous value. All this is to say that if we are multiplying by a power of 10, we can always just move the numbers in the place value. 3 times 10, the 3 is going to move 1 place value up to become 10 times greater. And that works even if I'm in a decimal on the other side of the decimal, I should say. So 0 and 16 hundredths. If I'm multiplying by 10, everything needs to move up 1 place, and then I'd end up with 1.6. Always remember your decimal system, very important. But here's the challenge. If you're feeling adventurous, you're thinking, you can get this. We don't have to have a decimal system. Our system happens to be 10 times greater because some people realised that would be the most effective thing a long time ago, and we've gone with it. But you can have other bases. Here's a challenge. If I have base 6, the number 1 looks like this. If I have the number 2, looks like this. Number 5 looks like this. But I'm going to make it so that I can only have 6 in each place value. That means the number 6 becomes this. That would be equivalent to what we would think of as the number 7. So here's the challenge. Using our base 6 system, I want you to convert some numbers. And to make life even more interesting, I'm going to write them in the good old Roman numeral system. Roman nose, Roman brain, Roman Abramovich. There's a number in the old Roman numerals. And this right here is why chalk, not so great. Very good for climbing though. So, you've got these 2 numbers, there's your challenges. If you want to see tomorrow, on Friday's, sorry, not tomorrow, Friday's Zoom meeting, we're going to go over the old challenges, see what we've come in our base 6 system. And my other question would be, is if I have our number system, if I move a number once up, it becomes 10 times greater. If I have a base 6 system, what happens to the value of that number as we move it up the system? Alright, till next time in the Hunker Bunker, we will be seeing you soon.